Welcome to Hartman Math. This is lesson 8.5, Infinite Geometric Series. So back in the previous lesson, we had this formula for a partial geometric series. And it works if we wanted to add up the first, 8 things. We would do s sub 8, and then we would do r to the 8th power, and so on. Now we're going to see what happens if our series is infinite. So the series goes on forever and ever, and we want to add up all the terms. Well, the formula becomes s, no partial, no s sub n, just s, add up all the terms, is equal to a sub 1 divided by 1 minus r. And this works as long as the absolute value of your r value, your common ratio, is less than 1. Because if it's not less than 1, there actually is no sum. It goes to infinity or negative infinity, there's no sum. But if the condition here is met, the absolute value of r is less than 1, then this works. And here's why it's going to work. So I want to go back to this. I want to do some calculator practice. So let's see if we could kind of come up with an r value that fits this description. So think of an r value that fits this description. Probably needs to be something like a decimal or a fraction, something like that. So if you thought a half definitely works. I want to use something that's easy to plug into the calculator. So I think I'm going to go with 0.7 as my r. And yours might be a little bit different. That's fine. So I'm going to go 0.7. So I want to look at what happens. Remember, as infinite, n keeps getting bigger and bigger, the number of terms goes towards infinity. So we want to pick bigger and bigger n values. So I'm going to take 0.7 and I'm going to raise it to a large n value. See what happens. So let's first try 0.7 raised to the 20th power. What do you get? Mine says 0.000797923, so obviously a pretty small number. Let's do another one. Let's pick a bigger n value. Let's do 0.7 raised to the 50th power. And my calculator says 0.000000018, even smaller. All right, let's try 0.7 raised to the 200th power. The display's a little bit different that it says 1.046183829 times 10 to the negative 31st power. So that's in scientific notation, suggesting that we take the decimal, which is right behind the 1, and slide it to the left 31 places. So there would be 0.30 zeros, then the 104, and so on. So that's a very small number. Let's do one more. 0.7 raised to the 5,000th power. And the calculator says 0. Now, technically it's not 0, but the calculator cannot tell the difference between the number it is and 0. It's that close to 0. Because the farthest it can go, essentially, is a point with about 99 zeros and then a digit. So it's obviously very, very small. And 5,000 is not even that big of a number. If we're talking about going to infinity, we should be talking about 0.7 raised to the 5 trillionth power. So what happens then is that when we take our appropriate r and we raise it to a gigantic power, like we would for an infinite, is this becomes 0. So it goes away. We get 1 minus 0. 1 minus 0 is 1. That's why our formula becomes this, because the r to the nth power just goes away. So example number 1, 49 plus 42 plus 36 plus 216 over 7 plus ... That's the key part there that says it keeps going. Find the sum, and it's not saying find s sub something. It says find the sum. It goes forever. So this is infinite. So the first thing we got to do is figure out if it's appropriate. Can we find the sum? Does the r value work? So remember, to find the r value, take one of the terms and divide by the one before it. So we can do 36 divided by 42, 42 divided by 49, whichever way. We reduce that and we get 6 over 7. And the absolute value of 6 over 7 is 6 over 7. And that is less than 1, so we should be able to do this. Okay. So we're going to do S equals A sub 1 divided by 1 minus the R. We're not going to totally rely on the calculator because we don't want to get a decimal that's not exact. I'm not sure what will come out here. So 1 minus 6/7 is 7 over 7 minus 6 over 7. So that's 1/7. 49 divided by 1/7. Now we don't want to divide by a fraction. We would much rather multiply by its reciprocal. So we're going to do 49 times 7 over 1, which is just 7. 49 times 7 is 343, and that's our answer. You try this one, find the sum, ... goes forever. Pause the video here until you've got your answer. Our R value is 48 over 96, or 12 over 24, and that's a half. So we're talking about 96 divided by 1 minus a half. 2 halves minus 1 half is 1 half. So let's not divide by the fraction. Let's multiply by the reciprocal. And you get 192. Example number 2. We know the sum. We know the first term. Find R. We're just going to do some algebra. We're going to solve for an unknown. In the formula, here's our formula, S equals. So substitute in what we know, 36, 12, we don't know that. All right, so to undo the division, let's multiply both sides by 1 minus R. And then we've got some choices. We could distribute, or we could divide by 36. If we distribute, it looks like this. Well, let's subtract 36 on both sides. Let's divide both sides by negative 36. A negative divided by a negative is going to be a positive. And that will reduce to 2/3. We found R. R is 2/3. What would it look like in sigma notation? Remember, sigma signifies a sum, lower limit of summation. Up top, you're going to see the infinity symbol. That's what says it goes forever. So we recognize this as an infinite geometric series. Geometric because this is an exponential expression. Would it qualify? Here's our R right there. Remember, we learned that before, that this whatever's being raised to the power is our R value. The absolute value of 2/5 is 2/5, and that is less than 1, so we're good to go. If we look at what does the series look like, plug in a 1, we get an exponent of 0. 2/5 to the power of 0 is 1, times 10 is 10. If we plug in a 2 as the next one, 2 minus 1 is 1. 2/5 to the first power is 2/5. 2/5 of 10 is 4. And if we plugged in a 3, we're talking about 2/5 to the second power, so 4 over 25 times 10. As a fraction, you would get 8/10 plus ... So that's what it looks like. And the key piece to that for us, for our formula, is right there, the A sub 1. So we're going to do S is equal to 10 divided by 1 minus our R value. So 1 minus 2/5 is 5 over 5 minus 2 over 5. So we're talking about 3/5. Let's not divide by the fraction. Let's multiply by the reciprocal. So we're talking about 10, which is essentially 10 over 1, if that helps. 10 times 5 is 50. over 3, and that should be our answer. Could not do it as a decimal, as it would not be exact. And we're going to finish up with this U try, so go ahead and pause here until you have your answer. So let's take a look at what the series looks like. Plug in a 1. 1 minus 1 is 0. 3 to the power of 0 is 1. Times 4 is 4. All right, let's plug in a 2. 2 minus 1 is 1. So 3 to the first power is 3. Times the 4 is 12. Let's do one more. Plug in a 3. Exponent becomes 2. 3 to the second power is 9 times the 4, 36. It is going to infinity, so we say dot, 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 just keeps going forever. All right, so if we did the formula, we would be talking about a sub 1 divided by 1 minus r, or divided by 1 minus 3. 1 minus 3 is negative 2. You would get, using the formula, negative 2. Now let's look at it. Is that even possible? How can we add up 4 and 12 and 36, and these are all positive numbers, add up a string of positive numbers and get negative 2? I don't think that's reasonable. That's not possible. Why is it not possible? Because there's no sum for this one. Our R value is 3. The absolute value of 3 is 3, and that is not less than 1. So the formula does not work for this because there is no sum. And that's it for today. See you next time.